This section is 18.1 day 1, so it's on quadratic functions. So we need to discuss really what a quadratic function means. Quadratic function is when you have an equation where you graph it and you get something that looks like this. Or it can be over here, or it can be up. But it's either basically a smiley face or a sad face. What it can't be is something that looks like this. It won't be like this, or the other way. So it'll always face up or it'll face down. So this will be interesting if I can teach this way. I don't know how else to insert the graph from your textbook, and it's really hard if you have to have your textbook open while I'm talking and then try to find which graph I'm talking about. So I'm taking a picture of the graphs on my computer. So there's probably an easier way, but I don't know it. This is a parabola of a hotel revenue. So say you stay at the hotel, if you rent so many rooms, then the price of the rooms go down. And so the hotel makes money as you're renting rooms, but then at some point it starts losing money. And so this parabola represents the hotel's revenue and how many rooms can be rented and how much money they're making. So a little bit of vocabulary. On a parabola, this is the vertex. Okay. This is also going to be the maximum. And we'll talk about that a little bit later of why that's a maximum and what a minimum is. But this is also a maximum because that is the max point that it hits. That's as high as it goes. Let's see, it opens down. Okay, and this opens down, and what you're going to find is, like, if you have the equation to this, they tell you how to, they tell you to find the equation. You don't need that right now. The equation ends up being f of x equals negative 2x squared plus 80x. And they talk about how they derive that equation. You don't need that right now. What you need to know is that this is the vertex, that this is a parabola, it opens down. You're going to find out that the reason it opens down is because of the negative in this position. This position right here is called the A. Okay, this is called negative 2 is called A. 80 is called B, and because there's no number back here, we can call this C. And we'll talk a little bit more about that as we go through. I'm just trying to throw some stuff out there for you. What you do need to know for this class is like how to look at the parabola and how to figure out what the vertex is. So at the vertex, this point right here, if I asked you what those were in ordered pairs, you'd say 20 for the x and 800 for the y. And you'll want to know, they'll ask you questions like, what does that mean? What is the vertex and what does it mean? Well, this means that at 20 rooms, it's going to cost me 800, or the hotel revenue is going to be $800, and from then on it's going to decrease. And there's other things about the graphs that we'll go through as we go through here. Oh, the other thing is the axes of symmetry. We're going to talk about that as we go too. What that means is that there's a line at which this parabola becomes symmetrical, meaning that this side mirrors this side. So this is called the axes of symmetry. And they'll ask you for that line, that axis of symmetry. Well, you notice the line is vertical, and so vertical lines are always x equals. Well, what is the x at that point? The x was 20. So the axis of symmetry is x equals 20. The line at which that symmetrical picture happens. So the next section, they show you an image that looks like this. I think it's 18.2. And they're just showing you what I just taught you. They're just showing you where's the vertex. Some of them face up, some of them face down. What does a parabola look like? They're going to start asking you for that point of vertex and the axes of symmetry. So you can see here on this parabola, the vertex is the point 0, 0. The axes of symmetry is going to be the line that splits it in half, and that ends up being that x axis, so that's x equals 0. Again, your axes of symmetry will always be x equals. It'll be whatever the x coordinate is. That's how you'll write your axis of symmetry. But your axis of symmetry is a line, so it has to be x equals some number. It can't just be my axis of symmetry is 0. You have to have x equals. So like on this one, your vertex was the point 0, 2. It's the highest point. And your axis of symmetry, again, was x equals 0. So on this, let me change colors here for a second. On this one, I might as well teach you this as we go too. This one is facing up, right? The whole parabola. And so, let me get rid of some of this stuff in here. This parabola is facing up. And one of the other things that you have to name from a parabola is whether it's a minimum or maximum. So if you look at this line, as you're coming down this line, at this point, this is the lowest line, the lowest point in the parabola, and then it starts going back up, right? So this right here is called a minimum. And that minimum is the lowest point that you see in there. The minimum is the point 0, 0. But really what you're looking for is that y coordinate, because the x coordinate can go right and left, but the y is the one that tells you the lowest point. Okay, so on this one, this parabola goes up and over, it faces down, it opens down, so it has a max. It's kind of opposite of what you think, because it's facing down, but yet it's, you think, oh, minimum, but it's a maximum, because if it faces down, the highest point it reaches is right there at 0, 2. So its max is where the y is 2. And they'll ask you, like, what is the y coordinate of the graph? What is the minimum y coordinate of the graph? Or they'll ask you, is there a minimum or a maximum? And what is that? You would just state it's 2. The y coordinate is 2. So if you look at this last one, is this point right here a minimum or a maximum? That one's a minimum because it's the lowest point in the parabola, because the parabola faces up. So the lowest point in the y coordinate would be -1. The x coordinate's not going to help you say what a low point is, because it could be over here, right? And the x might be negative whatever, but it's still not going to explain how low the parabola goes. If the parabola is moving up and down the y-axis, then the y coordinate is going to give you that definition of a minimum or maximum. So now you try it. On these two examples, what would the vertex be? Let me get my pen here. What would the vertex be? Is it a min or a max? And what's the axes of symmetry? So you might want to pause it while you try it. Okay, so for the vertex is that point right there. So the x is 1 and the y is -3. Okay, that is a minimum because it's the lowest point. And if they ask you, sometimes they'll ask you what is the y coordinate. So the y coordinate is -3. And the axis of symmetry, remember, is that line that breaks it in half. And it's a vertical line, so it's x equals. And then the easiest way is to just look at what you wrote here. Whoops, xy. Let me erase that. Look at what you wrote here for your x coordinate. It'll always be that. X equals 1. Okay, so let's try the other one. Let me erase this part. Let's try figure 18.4. So the vertex is right there. So the vertex is a point 2,4. It has a maximum. Whoops. It has a maximum. And the maximum is the y coordinate of 4. And the axis of symmetry is x equals, and it runs right here, so it runs through this 2. So x equals 2. So parabolas come in the equation of ax squared plus bx plus c. That's kind of the format, okay? But these, the a and the b and the c, are numbers, not letters. So there's always an x squared. So you probably dealt with linear in your last math class where they make a line and it was always like y equals 2x plus 4 or something. When you start putting this exponent of 2, that's when you get the parabola. Because we've learned that if you have the exponent of 2, you know how we solved equations, every time there's a squared, then we factor it, and then there's 2 answers, and then we check to see if they're right. So that's why the parabola, 2 sides to it that look the same, because there's 2 answers. So if you have an equation like, let's see, let me pull one out of the book here. So if I give you the function f of x equals 2x squared minus 4x plus 1, that means that a is equal to 2 because it's in that first position. It's next to the x squared. B is equal to -4. Notice how I took that negative with it, just like when I asked you to bubble. Okay, and then C equals 1. These letters, these numbers in these positions will help you find a vertex without having to graph it. It would not be fun if you had to graph every single parabola to find a vertex. Why vertexes are important in parabolas. Parabolas actually are really important in real life. They have a lot of applications. Anything where you throw anything or a projectile, or even like you saw within business where something comes up and at some point it's not feasible to afford it anymore, and then the cost goes down. So parabolas really, there's a lot of real life application to them. You'll probably get quite a few questions, I'm assuming, on that final about asking you things about the story within the parabola, and we'll go over those. So one thing about it is you can find a vertex without having to graph it. And you're going to want to memorize this formula. And the book also kind of warns you of that too, that it's a useful formula of parabolas and use it all the time. And you know that you can't use your notes for the final. So the way you find the vertex is you can find the x coordinate to the vertex. You know how the vertex has an x and a y? Well, there's a way to find the x coordinate, and then once you find the x, you can plug it in to get the y. So you can find the x by taking -b over 2a. So if I had this parabola, and all I had was the equation to it, I could find the x coordinate by going like this. Negative, and my b was -4, so I'm going to have a -4, over 2 times my a, which was 2. And if I solve that, negative of the negative 4 times the negative 4 is going to be positive 4. 2 times 2 is 4, so I get 1. I know that my x-coordinate is 1. If I know my x-coordinate is 1, well then I should be able to plug it back into my original function to find y, because isn't f of x the same as y? So I'm going to erase here just so I have a little bit more room. So now if I want to find y, I know that y equals 2x squared minus 4x plus 1. And I know that my x was, I know my x was 1, so I'm going to go ahead and put 1 in here for the x. Okay. You can plug that whole thing into your calculator. Just make sure that if x is ever negative, that you use parentheses on your calculator, because when you square it, your calculator won't bring that negative with it. So just fair warning. It's okay to use parentheses all the time on your calculator. So you could just punch this right into your calculator. You can also solve it by hand. So I know I have to use my order of operations, so the squared comes first. So 1 squared is 1. I know that multiplication comes next. So 2 times 1 is 2, minus 4 times 1 is 4, plus 1. 2 minus 4 is negative 2, plus 1 is negative 1, so I know my y is negative 1. So now I know my vertex. Remember, the vertex is an ordered pair. So the formula only gives you the x, and you have to plug it in to get the y. I would strongly suggest you learn how to use your calculator to plug all that in. Well, right here. Because it's easy to make a silly mistake. You only get 50 minutes for the final. You know, I would get used to just plugging that right into the calculator and letting it do it, so you don't make an error with a negative. So with that formula, why don't you try this next one? So try f of x equals x squared minus 1. And I want you to find the vertex. And then we're also going to talk about the axes of symmetry. How would you find that without having to graph it? Okay, so remember, and just keep repeating the vertex to yourself. The negative, you know, it's x equals negative b over 2a. And then you'll get used to it. Again, you're going to want to memorize that one. So you might want to pause this and try and find the vertex on your own. I'm going to go ahead and write what A, B, and C are. You don't have to do this every time, but I'm doing it just because it's a visual in the notes and I want you to understand it. A is always in front of x squared, and there's an understood 1 right there. So we have the 1. B is always in front of the x, and since there is no x, we have 0 as B. And C we haven't really used, but C is the negative 1. And we really don't need that right now, but I want you to know that it's there for later. So I'm going to take my vertex formula, and I'll tell you what I tell when I teach public school. What I tell those students is every time you go to use the formula, make yourself write the formula. Then you'll memorize it. They hate me for the first part of it, but they remember it, and then they go, yeah, that was good. So I'm going to go negative 0 over 2 times 1. Well, that's going to give me anything. 0 over anything is going to give me 0. And so I know my x is 0. So I'm going to go ahead and put my x up here before I forget. And now I want to plug it in to get my y. So I called it y last time I do that, but it's really f of x. So f of 0 equals 0 squared minus 1. Remember, I kind of glossed over that. Remember, f of x is really like saying y equals. So if you want to write y equals, you can. Oops. So if I wanted to find f of 0, it's going to be negative 1. So I know my y is negative 1. So my vertex is 0, negative 1. How do you find the symmetry from, the axis of symmetry from that? Think about this. If I graphed this, and I told you that if A is positive, it opens up. And this opened up, and the vertex was 0 for the x and negative 1 for the y. So the vertex ends up being right there, right here somewhere. Okay, so if this is the vertex, the axis of symmetry has to run through the vertex along the x. So the axis of symmetry is x equals 0. Flip back a few pages in this and look at the very first one that we were talking about when we were talking about axes of symmetry. Okay, keep in mind I keep telling you that it opens up, opens down, and how you know. I'm just throwing that out there for later. This is positive, the A was positive, and if you were to graph this on your graphing calculator, it would open up. So why don't you try the next one? Let me write it here. So the next one they had in the textbook is f of x equals negative x plus 1. Okay, so this one isn't in that ax squared plus b x plus c form. And so we want it to be. So if we look at this and we think about the order of operations, and we think that think about there being an understood 1 there, remember? So the order of operations says I have to square first before I multiply. My exponents before multiplication. So I'm going to go ahead over here and figure out what x plus 1 times x plus 1 is. And now it goes back to your foiling. Remember I told you how important it was that you could FOIL pretty good. So here it is, x squared plus 1x plus 1x plus 1, so x squared plus 2x plus 1. So I'm going to put that instead in there. So I have a negative 1 times x squared plus 2x plus 1. So now I can do my multiplication. Notice that I left those parentheses in there because originally this negative 1 right here is multiplied times this whole quantity after it's multiplied. Getting messy. So now I'm going to multiply my negative 1 through, and I'm going to use distributive property. So negative x squared, minus 2x, because it's negative 1 times 2, minus 1. So now I have the proper form. You always want to have the proper form before you decide what A, B, and C is. If you don't, that's going to mess you up. So A is negative 1, because it's right here. B is negative 2, and C is negative 1. So I'm going to use my formula for the vertex. A equals negative B over 2A. So x equals negative 2 over 2 times negative 1. So that's going to make a positive 2 on the numerator, and the denominator is going to be negative 2, which simplifies to negative 1. So I know my x coordinate is negative 1. Now I'm trying to find my y coordinate. So again, sorry about getting messy here, we're going to plug it back in to get the y. So we're going to take that original problem and plug it back in. So it was, f of x equals negative x plus 1 squared. Okay. Well, why don't we use Actually, why don't we save some time and use the one we already put in the proper form. So I'm going to use negative x squared minus 2x minus 1, so I don't have to FOIL again. But I mean, it doesn't matter. You can plug it into there too. I guess that would have been easy too. Anyway, so this is negative 1 squared minus 2 times negative 1 minus 1. So negative 1 squared is positive 1, but then you have the negative on the outside. And that's going to make positive 2 minus 1. And if I were you, I would just use my calculator, and you're going to get 0. So I know that my y is 0. Again, probably it could have been easy for us just to plug it in here now that I think about it, because negative 1 plus 1 is 0, 0 squared is 0. We would have been there a lot faster. So, yeah, should have thought about that ahead of time. Either way, so your vertex is negative 1, 0, and your axis of symmetry is x equals negative 1. Okay, how about this one? I'll try to not be so sloppy on this one. That one's already in the nice form for you, so you can try that real quick. You're looking for a vertex, and you're looking for an axis of symmetry. So my A is 1, my B is 4, my C is 3. So I have x equals negative b over 2a. So x equals negative 4 over 2 times 1. It's negative 4 over 2, which is negative 2. So I know my vertex is negative 2 and something. I can also go ahead and do my axes of symmetry. Now I'm going to plug it back in. So f of negative 2 equals negative 2 squared plus 4 times negative 2 plus 3. I'm glad your book has this one in it, because it also gives me another chance to just talk again about how you would use your calculator. So in your calculator, if you're using this in your calculator, make sure it looks exactly like this when you plug it in. It's very important that this negative 2 is in parentheses. So if you're not sure where your parenthesis button is, figure it out, go to the college, let them look at it, call me, I don't know, take a snapshot of it. Also, last chapter, I didn't really talk about the calculator too much, about how you find cube roots and fourth roots. So if you're struggling with how to do that on a calculator, let me know and I can show you how to do it. So negative 2 times negative 2 is positive 4, plus negative 8, plus 3. Let's make negative 4, plus 3, and negative 1. So the vertex is negative 1. Negative 2, negative 1. Okay, so one thing I haven't really talked about that the book talked about, I wanted to stick to finding the vertex, finding the axes of symmetry, and I felt like they were kind of all over the place in the textbook. But also, how do you, in the textbook, they use this example, and they said, how would you graph this to find those things, and to find out if it opens up or opens down. We can already tell that it opens up because A is positive, but if you had to graph this, how would you do that? And they're wanting you to make a table if you go ahead and do that. So we're going to talk about how you do that. You could sit there and make a table and guess at what the points are, but how are you going to know you got that exact point at which the vertex happened when it came down and came back up? It'd be easier if you knew exactly where the vertex was and then could move around it and get some other points to graph it. And so you'd still find where that vertex is. So I showed you that on the last screen, and that vertex was negative 2, negative 1. So you would go over to your graph and go, okay, well, then I know that I go back 2 and down 1, I know that that's a vertex. So if I know that's the vertex, then I know that's one of the points. So if I want to know where the other points are, look around that point and pick some other x's. So what if I pick, x is 0 is such an easy one. That's one I always pick first. So what if x was 0? Well, if x was 0, we can find y by finding f of 0. 0 squared plus 4 times 0 plus 3. So if I solve that, f of 0 is going to equal 3. So then I can go over to the graph and go, okay, well, x is 0, y is 1, 2, 3. Well, the other side of this, I could sit there and put some other points in there. But if I know I've got everything right now, and I know that that point is a vertex, ooh, let me make that skinnier. Whoops. If I know that this is the vertex, then I know that this is the line of symmetry. So if I know that's the line of symmetry, think about this. If this point 03 is 2 jumps from the line of symmetry, there must be a number that's, or a point that's 2 jumps the other way. I should be able to put that on there. So I'm going to go ahead, issues, and put that point on there. Now that saved me time. I've got 2 points. So maybe I want to know maybe I want some more points because I want to be real accurate. How wide does it open? It doesn't ask you that this time around, but that'll be important later. So maybe I want to guess and I want to say, okay, well, I'm going to put 2 in here and see what happens. Or I'm going to put 1 in there and see what happens. And you go ahead and you get other points and you put them in there. And now, and parabolas are rounded at the end. They aren't a V. They're round. They're like a U. So now I know that that parabola faces up. And again, it faces up because that's positive. And then I know my axis of symmetry is x equals -2. And I know that my vertex was -2, -1. If you want to try another one of those examples on your own, I'll only do one of the table, but there is another one. It's on page 1155, and it takes 18.2. It has a table on 18.2, and it asks you to graph it. So you could try it on your own without looking at the graph. So here's a weird example, but we're talking about eating pizza. I can kind of relate. You know how you eat a couple pieces of pizza and it tastes so good and you can't stop? In our house it's like that, and then everybody eats too much and they feel gross. So they graphed this, the amount of pizza until this guy doesn't have the satisfaction anymore. So here's the graph, and it's on page 1156, and it's right out of your book. It's figure 18.9, and the equation to it is written here. And they ask you to find the vertex and find the given maximum slices to provide satisfaction. So you can imagine the guy's starting to eat, his satisfaction's coming up. He's going, oh, this pizza's so good, and then he's going, ew, I don't feel so good. And then he eats more, because we always do, and then you really don't feel very good. So the maximum satisfaction would then be its vertex at the maximum point. So they ask you to go ahead and use the formula, and it's x equals -b over 2a. And they want you to use the formula and then look at the graph and see if it looks like that should be it. So if you slide that in there, b is, whoops, I forgot. I was thinking b can't be 0. Sorry, there's an x there. B is 50. And then a 2 times A is negative 625. And so if you plug that into your calculator, you'll find 4. So you know that X is 4, and you can see right here that his satisfaction level started going down after 4 slices. There's also a question like this. This is more typical of what you'll see on a test, on the final or whatever test you're taking that would cover algebra. And it's more realistic. They're going to say, like, at what point, if this guy hits this baseball 3 feet off the ground, you can figure out how high it is if you know the time in seconds that it left the bat. And so this formula right here, they'll give you. And so the negative 16 in the formula just represents the gravity. And you'll see that in a lot of formulas. You'll see negative 16 t squared, and then the other numbers will be depending on what's happening in the story. And so they give you that equation, and they ask you, what's the height? Let me change colors here. What is the height of the baseball when it is hit? Well, obviously you can see from the picture that it was 3 feet, but a lot of times they won't give you the picture, and they'll say, what is the height of the baseball when it's hit? Well, when it's hit, how many seconds is that? That's 0 seconds. Well, if t represents seconds, then you should be able to figure it out without the picture. So you should be able to go, well, I know that the height of the baseball would be before it even got hit, or at that 0 seconds. So I should be able to plug 0 into the t and find height. So if I do that, I find that the height at 0 seconds is 3 feet. So I can answer that question without this picture at all. And you want to make sure that you understand that, because a lot of times they will not give you a picture. Most of the time on a final, they'll just give you the story that goes to it. So then they say, determine the maximum height of the baseball. Well, we talked about, a baseball, when you hit it, it's going to come up if you graphed it over time, and it's going to come back down. When it left, that's 0 seconds. And when it comes back down, that's when it hits the ground. But at this point is the highest point. Well, you learn that that's a vertex. And so if you just use your knowledge of vertex, you can look back up at this formula, and it's negative b over 2a. So you know that it's negative 16. Oops, I just put the a in the wrong spot. Good thing I write the formula down. Good thing I follow my own advice. Negative 96 over 2 times negative 16. And you'll find that that is 147. Just go ahead and use your calculator for that. So you know that that's going to be the x coordinate here. Well, you know x are seconds, so, or x is height. And so you know that it's going to be 147 feet at the vertex. That's going to be the highest point. So that's going to be the highest point that baseball hits. Sometimes they'll ask you, when is it going to hit the ground? And we'll talk about that on another video. So this is the last slide. On a lot of the parabolas, they'll have a story problem where you have to figure things out, or sometimes they'll have a graph where you have to interpret certain things from the graph, and it will be in the context of the situation. So on this one, they said, interpret the graph. So if you were to interpret this graph, here's the hotel revenue, and you want to look at what the x and y axes are, rooms rented and revenue in dollars, like we started this section. So they're bringing this idea back. And they want you to be able to now say, well, as you increase renting rooms, the hotel revenue starts to increase. But at a certain point, if somebody comes in and rents so many rooms, then it starts to decrease and they start to lose money. Okay, so that would be interpreting. You have to interpret that it's increasing and what that means with rooms and what that means with dollars. Make sure that if you're on any kind of a final that you're using the words, not just the X and Y. You're saying the revenue's doing this, the rooms are doing this. The next question they ask is, what is the maximum revenue? Well, the maximum revenue is, you can see, the maximum revenue is right here at the vertex. So the maximum revenue is $800. So the most they're making is $800. And they'll say, how many rooms should be rented to receive the maximum revenue? They're testing to see if you know what the X and Y means. Well, down here, the X is rooms, and so you can see that at that point, 20 rooms, at 20 rooms, they will receive $800, and then it starts decreasing. They could also ask you stuff like, you know, how many rooms do you, or how much would the revenue be if they rented 30 rooms? Well, then you're going to want to look at where 30 rooms hits the parabola, and that's $600. So you want to be able to answer questions about that, and you should be able to say, well, you know, if you rent 30 rooms, their revenue is going to be $600. We won't ask you to write a formula in day 1 of 18.1, so you don't have to worry about that question that was in there. And then, yes, that's it. That's it on 18.1. So now you can do your assignment.